the natural logarithm, which we designate as Ln. When you study logarithms, so as you can see here, so there's the equivalence between an exponential and then a log, which is basically the inverse of the exponential function. And in particular, so this base b, we assume that it is greater than 0, and we also assume that it is not equal to 1. Now, there is one particular base which is super useful for us as you continue on in mathematics and then you utilize applications, and it is the base that we use, okay, Euler's constant for. And because of that Euler's constant, so what we do is we say B is basically equal to the Euler's constant, which is E, 2.71, and so on and so on. You can refresh yourself, or if you want to know a little bit more about Euler's constant, I'll put up a link up above there. Now, that Euler's constant, once we use it as our base, it actually simplifies, or at least we simplify for ourselves. And to designate that we have that special base of E, okay, we change this log. So instead of writing log of the base B, in this case it's a log of the base E, and that we write as simply Ln, which is pronounced ln. So instead of continuously saying log of E right here, we have decided to give that a special, unique name and symbol, which is ln, and it's called the natural logarithm. It's natural because it applies to various applications from engineering and onwards, and it is used rather often. So what we have is, it doesn't change anything for us. So, we can still say y is equal to, now our base is very specific. E is an actual number, and because it is greater than 1, it's going to explode on us as an exponential. I'll show you that in just a second. And then its inverse, so if you want, okay, you would write that the inverse is simply the ln of y, and we do not write the actual base in there. As soon as you write, okay, Ln just stands for natural logarithm, and we don't have to write the base. So this natural logarithm is super useful. Now, on your calculators, you actually do have 2 special logs, and pretty much all scientific calculators will have that. Now, in the world of apps, now we have a lot more functions available to us, but in the standard calculator, you typically see, 2 special logs. So log of base 10, which you will notice is just simply written as log. It assumes that it's base 10. And then we have the second one, which is log of base E, which we write as just Ln. Now, it can be capital or lowercase. It doesn't really matter. But these are the 2 distinguishing features that we see. So if I pop out a calculator within here, so notice I do see a ln right there. Okay, so that's 1. And then I will also see, let's see if I can find one. Yep, and then I see a log. So both of those 2 assume. Log just assumes that the base is 10, and ln assumes that the base is E on your log. Now, everything else holds. So, you have studied for logs various properties. Well, the same properties hold for ln. Because all you're really doing is you're just changing the base to a very specific number, and it's the constant, Euler's constant, E. So for instance, if I go back here, and I present here to you, okay, and I remind you of the property, so if this is B, okay, so if that is the B, which is the base, okay, and you change that base and you say, now this is log of E, okay, of 1, it's still equal to 0. However, we wouldn't write it as log base E, okay, we typically will just say ln of 1 is equal to 0 because we know that the base is Euler's constant. And that holds true for all of them. So for this one, we would write ln of E, okay, is equal to 1. And within here, you would write ln, again, ln means log of base e. Okay, so ln of e to the k is just equal to k. And in here, so if you would have this e, okay, this would be ln k is just equal to k. So all of those properties hold that you will see them. Now, you also had these major properties, and those also hold. So you can take any of them and replace the log b with log e, okay, or simply ln. So for example, I will take kind of maybe two of them just to show you. So for instance, if I take the first one, I can rewrite this with ln, and this is of any two numbers. If you take the ln of any two numbers, this simply means ln of m added to ln of n, which is exactly the same thing. And you can replace every property like that. And in particular, this last one right here, which we utilize of changing the base, especially when we're only allowed to use a scientific calculator, let's say on a quiz, on a test, you know, so very often we use log, okay, which has the base 10, but you can change this and you can rewrite this as simply saying ln, okay, of m all over ln of, and in this case, b, okay, and that would equal to log of base b of the m. You can just simply use ln, all right, so you can use that. So those properties do hold. That is the natural logarithm. Now, how it looks exactly like an exponential, okay, or an inverse to the exponential. So let me just show you. I'll pop up Desmos here, so kind of our favorite tool. So if I had y, okay, so within here, equals to e, so notice e to the x. So it should look like it's blowing up because e is 2.71 and so on and so on. All right, so that's how that's base e. And now if you take the inverse, so it's going to be now ln, okay, of x, and notice that what you have is you're going to have a nice inverse. And remember, an inverse means that it's a reflection in the y is equal to x. So that's a ln of x. But really what it is ln, okay, of x means log of base e of x. So we just kind of drop it. And that's because that Euler's constant is so widely used later on in mathematics and in sciences and applications from engineering that you do want to be familiar, and you should start introducing yourself to this ln over and over. And that is it for this particular video. I just wanted to let you know what that button of ln is. Nothing special. We've just set our base equal to Euler's constant E. See you in a future video. Bye, everybody.